All right, Chrisanti is back. All right, guys. So here we are. Come off of this here. All right. All right, guys. So, what was the last thing we did? What was the last thing we did, class?
Sir, atomic structure part 3, sir.
Oh, atomic structure part 3. Yeah. So yeah, and what did we speak about in that class?
Sir, energy level means the further it goes from the atom is the more energy the shells have.
Oh, okay. Very important point there. Hope everybody heard that. All right. Everybody heard what Tiana said?
Yes, sir.
Yeah. It's a very important point. All right. The further. All right. So yes, the atom starts from the middle. All right. That's the important thing for you guys to remember. The atom starts from the middle. So when you're doing when you if you were like God, then let's put it that way. The Bible says that you would be like God, knowing good and evil. It doesn't say you will be God, but you will be like God. So you have the ability now to create things. All right. So if you're creating something, all right, you're gonna create, you're basically going to create what you'd say is the most important part first. All right. So for example, when you were being created, right, you were created from two simple things. Right? But you know those two simple things that you were created from? It's just like the atom, you know. What two simple things you were created from? Nobody know? Right. Come on, guys. You can't spend this long in school and don't know what two things you come from. What two things cause you to exist? Two simple things. Right. Did anybody hear that a bird drop you off at the doorway? That's how you born? That's how you came? Nobody came to earth like that? A big white bird without, you know, the cloth wrap around him beak with you inside there and him just drop it off at the doorway and fly away.
No.
All right. Nobody experienced that. All right. So some persons actually were born that way, you know. At least that's what their parents tell them. But then if you never born that way, then how you born then?
Sir, for your mother and father, sir.
All right, fine. We know. But then, come on, man. You don't sound like a chemistry student, man, in grade 10. What's the sound? You have to give me more than that. Person in grade 4 or grade 3 could
Where
tell me
my
that.
eggs, sir?
Thank you very much. I'm afraid to call the name them. And that is the problem. Sperm and egg. You understand? Those two simple things. So the same thing with the atom in the guys. The two simplest things where atom create from is the proton and the neutron. Just like how sperm and egg make people, proton and neutron make atom. All right. So remember, say now you're creating the atom, you start with the nucleus part first. All right, guys. The nucleus is the most important part of the atom. All right. Now, You know, Miss McDonald probably teach you the biology and we tell you how the rest of the story go with the sperm and egg. But just know, say, the sperm and the egg also have a nucleus as well. All right. And it's those two nucleus that combine to form you. So the head of the sperm and of course, the body inside of the egg has a nucleus. The two of them merge together and exchange information. Some information come from your father, some come from your mother, right? And then after about 38 weeks, 36 to 38 weeks now, the information done exchange, everything farm up, and then you get where you forget from your mother and get where you forget from your father, and then you come out looking the way that you look. All right. And that is the story. So same thing here with the atom. Right? Same thing. The only thing is that with the atom, it's like we could say Bible say God make everything, but scientists figure out how it was made and is trying to make their own. All right. So them reach a point where now them can make elements. Any element that come after 92 on the periodic table, they were made by persons. Okay, they were made by persons. So God made the first 92, man made the next one. So if you check the periodic table, they might have about 120 elements, but God never make any after 92. All right. So, and we're going back to that periodic table, which you guys forget because you have so much things on your mind these days, which sad though. But everybody remember this periodic table here?
Yes, sir.
Yes, sir.
All right, the periodic table here. And if you notice that we catch 92, number 92 is down here. You see here. 92 is down here. It's just each up in the corner down here. So see number 92 here. So put a use a red marker and select it. So you understand what we're talking about here. Number 92 is here with the symbol U, which stands for uranium. All right. So when you reach grade 11, we'll learn more about uranium. So uranium is like the heaviest natural element on Earth. So you could say it's the heaviest element that God created. All right. And also it could be the most dangerous one. Could be. Could also be the most useful one too. All right. But that's for you to decide. Unfortunately, Jamaicans don't know a lot about uranium. Probably see it in some action show, when place blast up and bomb go off somewhere or something. But you as chemistry student, you have to be different from ordinary Jamaicans, guys. You have to know important things about stuff around you. Uranium is one of those things that we're going to talk about later on. All right. So with that said, guys, the atomic structure begins with the nucleus. And if we were to look at the nucleus of uranium, we will find that there are 92 things inside of it. All right. So imagine a very small atom, very small, and you can pack 92 things. So if you do your hand like this, can you pack 92 of anything in your hand? Like just do your hand so and try pack something in there to fill the space. All right. Could you find 92 things that could hold in this little space here?
No, sir.
No, well, no. Even if you say yes, it will be probably difficult to find it. So that's the point I'm trying to get at now. When you're going to realize that when an atom have a whole heap of things in the nucleus, the atom start behave funny. In fact, the atom, and just like uranium is a very strange atom. All right. Strange atom because with those 92 things that are packed in the middle, the things that are in the middle of the uranium atom, they are very unstable. Them tend to move because they vibrate, and then any little thing, like if you blow a little dust on it now, the atoms them absorb that energy and them start vibrate. And so they realize that uranium could be used to make bombs. Also, uranium could be used to, well, It can actually be used to create energy as well. You know, create a lot of electricity from it. Again, those who physics will learn more about that. All right. But the point is that the atom begins from the middle, and it's the middle of the atom that tell you what the atom will be like on the outside. All right. So if it have 92 things there, it's actually 92 protons. So we still don't talk about the neutrons yet. If we do the maths here, we can work out the number of neutrons that uranium have. Let's go back to this screen. So if you remember how to do those things here. All right, that's possible question on CXC that I saw before. Let's just change the color here and let's introduce this. All right, and the question of the day is, all right, the question of the day is how many neutrons are found in the nucleus of all right, so look at this way the question is asked here. All right, everybody seeing this question?
Yes, sir.
All right, good. So we get some information here.
Sir,
Yes.
Say I go subtract 235 from 92, so I get the answer.
Well, you're going to subtract 235 from 92.
Yes, sir.
All right, so if that means I'm going to have 92 here, and I'm going to subtract 235 from it, and I'm supposed to get what number? All right, let's put that in the calculator. And we get that. So I have 92 minus 235.
143.
How much you going to get?
143.
Can't get 143. Because watch this now. See, I put it in my calculator. What you get here?
It says negative.
Negative 143. So can we have a negative number of neutrons? That means we owe the atom some neutrons, you know. And God made it with neutrons. So how is it that we're owing the atom here? It can't be. We're violating creation here. So what's happening? Why we get minus 143?
Sir, you must set 92 from the 235, sir.
Oh, that make better sense. All right, we could try that then. 92. So you see, guys, this is the problem I find that a lot of Belfast students, when I'm talking about subtracting, them have the thing the wrong way around. Put the thing the right way. When you're working on something, right? Say what is it that you're doing. If it's 92, you're taking away from 235. That's different from saying 235 from 92. If we do it this way, as O'Neill say, what number we're going to end up with?
143, sir.
Oh, so we realize say, oh, Lori, you have joined us. Well done. All right. So yeah, so we have 143, and but then this is positive, so this is good. So this is the answer. So good try, Kristen. But remember, next time you must look at what you're doing before you put it forward, because you know you'll lose a mark for this in an exam situation. All right. So this is how we work it out. All right. So guys, this is the practice. I expect everybody to be able to work out the number of neutrons in an atom. We did spend time on that. This is uranium, and the periodic table is going to see 235 here, and you're going to see 92 there. All right. And so the 235 is actually the mass number. All right. This 92 here is the proton number. All right, the number of protons. So again, 92 protons in the uranium atom. Remember, guys, this is the heaviest atom that was created by the creator. All right. Some of you call him God. Some of you Some people call him Buddha, some people call him Allah, some people call him Jah, you know, whatever you call him. Made this atom with 92 protons. All right. So hope everybody understand what we're doing here. All right. So if I said other questions similar to this, you should be able to do it. All right. Now, as it relates to atomic structure, guys, all right, you should be able to draw the structure of any atom from 1 to 20. All right, guys, I hope you understand what I'm saying. All right, any atom, all right, on the periodic table for the elements 1 to 20, you should be able to draw those. All right. Now, let's do something here. All right. In fact, we're going to go back to this model that we had from the previous class. All right. And let's change the screen. It's new share. Screen 2. All right, everybody seeing the screen here?
Yes, sir. Yes, sir.
All right, good. So, all right. So now, yeah, and then we were recapping until we reach here because I think it was Tiana. Yeah, Tiana, you started out by saying that you're saying that the energy levels tell you how far you are from the atom, which is the middle of the atom. So, all right. So we say that these dotted circles are what again? Or the dotted circles around the represents the
shells.
the shells. Very good. Which another name for the shell is what? Orbit. Very good.
The orbitals are energy level.
Very good. All right. So that's learning. So learning has been taking place. That's commendable. So that's good. So these are the energy levels. All right. This X marks where? Which part of the atom is marked by X? Very good, Khadija. It's a nucleus. All right. Was it Khadija?
Yes, sir.
Yeah, very good. And so that X there marks the nucleus. And if we try to put electrons in the nucleus, what's gonna happen? Will it stay there?
No, sir.
Okay, let's try it. No, right. It doesn't stay. I drag it to the nucleus, but each time I drag it to the nucleus, it keeps going to where it's supposed to be. All right. So in other words, we wouldn't start by using electrons. We'll start by using protons. And pro means first. So pro means first. So therefore, that's the first thing. All right. So now neutrons now. Let's try and see what happens if we put the neutrons. Let's put them on the shell and it finds its way in the middle of the atom. All right. So notice that when we do that, the name of the substance changes. We have a substance called hydrogen now, but we have one side problem. This is not a hydrogen atom, right? It's not a hydrogen atom. You see this plus sign here, and there's an ion there. Can anybody explain that to me? Why is it that there's a plus here, and why is it that the word ion is up here?
It have more electron that it should have.
More electrons than it should have. More. You sure want to use the word more? What is the opposite of more?
Less.
Less. All right. So because so looking at it, very good, Christianity, because you're saying that are there any electrons there first of all? Are there any electrons on the shells right now?
No, sir.
No.
No. So therefore, and then there's protons in the nucleus there. So it has protons in the nucleus, but no electrons on the shells. So therefore, it's not an atom. It's an ion. All right. But
Sir, and they're not equal, sir.
They're not equal. Good. So very good. As atoms do have equal number of protons and electrons. That's true. But why is there a plus sign there?
Sir, because they have a positive charge, sir.
Okay, which part of the atom has a positive charge?
The electron, sir.
No, electrons cannot have a positive charge. If it don't have any electrons, it cannot have any positive charge. So you have to look at it again. The protons have the positive charge. All right, so understand what's happening here, guys. That there are no electrons here. Electrons have negative charge. So there are no negative charges here. So when you have a proton in the nucleus, there are no negative charges to make it neutral. So therefore, the atom will have the charge of the proton, which is positive. All right. So protons give atoms positive charge, guys. Don't forget that. All right. Protons give atoms positive charge, positive energy. Electrons give atoms negative energy or negative charge. All right. So hope everybody is understanding that today. All right. So with that said, guys, we're going to try and balance it. And so it's an ion now, positive ion, by the way. Did I give it a name, the word that we use for a positive ion in chemistry? Did I give you a word to describe
Radical,
it?
sir.
What's that?
Radical, sir.
Radical. All right. That's another name for ion. That's a synonym for ion. But yeah, radical is a word we could use instead of ion. But then we didn't tell you the name. All right, so atoms can have negative charge as well, you know. Let's let this hydrogen have a negative charge and show you what it look like. All right, so I'm gonna put the electron here. Electrons have negative charge. Then you see that this comes up, neutral atom. All right, everybody seeing that? Neutral atom here. All right, all right. But then if I add another electron to it, look at that. What happens? What happens here? All right, it changed from a neutral atom to what now?
Iron, sir.
What type of ion?
Negative.
Negative ion. All right. So good. So guys, what I'm saying to you now is that when we're talking about ions, right, we need to say whether they are positive and they are whether they are negative. Also, not only that, we should be able to say that, but we should be able to explain why an atom or why an atom could become a positive ion or a negative ion, because atoms do become ions. That's the reality. When atom reacts with things, it becomes ion, it becomes change. All right. So the same thing with you guys. Come in high school in grade 7, nice little children, nice little boys and girls who follow instruction and listen to the teacher and so on, and then listen to your parents maybe. But now you're in grade 10 and you're probably not listening to them so much, and you're probably gone astray. Am I speaking to anybody in this class? Anybody has gone astray? From
No.
first one, Abigail is saying no, she hasn't strayed. All right. Tiana is saying no, she hasn't strayed. All right. All right. Remember now, God made atoms, all right, and then now the atoms reacted with each other to become ions. And so we need to understand what is happening here then. All right, so let's remove the extra electron from hydrogen. So a neutral hydrogen atom has one proton and one electron. All right, and that's the story here. I think what I should point out here now is that with ions, so let's see, atoms are neutral, and as O'Neill had said earlier, since the proton number is equal to the number of electrons. So let's call that electron number. All right, ions now are not neutral, are charged because, all right, and I'm going to show this to you on the board in a second, but I just want us to understand what we need to learn here. ions are charged because the number, the proton number, and by the way, the proton number can change. It's only the electrons can change. It's that they have more or less electrons, but you can't change the protons in atom because that's what defines the element. All right, that is the I call that now. That is the framework of the metal. So you come in like, for example, you buy a Toyota car, all right, you buy a Honda, or you buy a Mark X or Axio, all right. Thing about it is, can you change the name of that car? Can you change the name of the car?
No, sir.
No, because no matter what you do to it, it's still gonna be a Mark X or Axio or a Honda.
Yeah, but I can change the symbol, sir.
You can change the symbol, but it still don't change the car. You see it? So the same thing here with the atom. We can change the electrons. We can put any amount of electrons it can hold. But what we cannot change the protons. All right, the protons is what define it. All right, protons have to remain the same. They are, and so that's why I say when you're building the atom, you build the middle part first. The middle part tells you what type of atom you're building. All right, so ions are charged because the proton number is not equal to the electron number. And so, all right, and today we're going to learn about those two types of ions because we are seeing from this little activity that the ion can be positive and also the ion can be negative. So ions may be plus charge or minus charge. So
Sir,
yes, go ahead.
sir, how much protons and neutrons, sir, does it take for it to be unstable, sir?
Well, as we say, anytime it it also need one more or one less. You just say one or more. All right, Tiana? One or more. So
Okay, sir.
yes, so you can add an extra electron. You can add 2, you can add 3, depending on how much the shell can hold. That's the important thing, Tiana, that you can add any amount as long as the shell can hold it. All right, so let me show you something here now. I put another electron here, so and it hold on that shell, right? Watch what's going to happen here now. Look, you see what happened here now? You see that? You see all the extra electron. Notice that the first shell can hold more than 2, you know. But you see that? I put it in the first shell and it end up going to the second shell. All right, so remember the first shell is the shell that's closest to the middle. And I drop it there and look at that. See, so all of the extra electrons, I can't put it on the first shell, it has to go on the second shell. And then that's it. So yeah, this is definitely as you put it, unstable. It's an ion, and as O'Neill would call it, a radical. So many electrons. So because you asked that question, really, what you would do to get the charge here, the charge can be calculated. It's like you're gonna say a +1. This is going to be +1, but then this is like 1, 2, and how many seen on the second shell? Nobody can count them. So there's 2 on the first, but how many are there on the second shell?
8.
8. All right, Tiana and Abigail saying 8. Definitely 8 there. So what you're gonna have is 8. 8 and 2 is 10. So 10 electrons. So the charge of this atom, or not atom, of this ion really is gonna be, well, 8 and 2 is 10. So 10 electrons here. So it'll be something like -10 plus 1. Because the proton has a charge of +1. And if you have minus 10, the number minus 10, and you're adding 1 to it, what is the answer? It's a simple there.
-9.
Okay, Khadija is saying -9.
So
Or,
I know just
or Tiana, you're saying it's -9, which
yes,
is
yeah.
indeed correct. That's correct, because that's how you work out the charge, you know, guys. And this is something that you're going to have to learn to do now. You're going to have to learn to work out the charge here. Let's reset this, carry it back to where it was. All right, I'm going to actually minimize this too. I'm going to tell you the symbol here. All right, so information that you need to have in your notebooks is going to be on in the screen shortly. All right, ions may be positive charge, or maybe negative, or negative, really. That's the adverb there. All right, so positive charge when it has more protons than electrons. All right, and it's negative when you have more electrons than protons. All right, so the ions now have two different names now where that is concerned. So the positive charge is called cation. The negative charge is called the anion. Let's go back to this screen. New share. All right, everybody seeing that?
Yes, sir.
All right. So, all right. So ions may be positively charged or negatively charged. All right. And in the case of that, no. More protons is a cation. So more protons than electrons. All right. Atom loses electrons for that to happen. To form cations. All right. So two important things about the cations. All right. One is that there are more protons than electrons, and two is that the atom would have lost electrons to create them. All right. For the anion now, it is the opposite now. So it has more electrons than protons. All right. And then, of course, we're saying that the atom gains. All right. So we're underlying lose and we're underlying gain. Atom gains to form anion. All right. Atom gains electrons to form anions. All right. So anybody have any questions here?
No, sir.
All right. Let me just change the screen here a bit. Yeah, it's there. Yeah. All right, let me know when you finish writing this one.
Finish, sir.
All right, that's Lori. Okay. All right, so
Finish, sir.
all right, Tiana.
Finish, sir.
Okay, that's Kristen. Good. All right, so again, what I want you to get from today's class, these words should be in your vocabulary now, cations and anions. All right. Because throughout the whole of chemistry, that is what we're going to really talk about, cations and anions. We need to be able to see how a cation is formed. And also explain what happens in when cation or an anion is formed. Let's see if we can get some visuals to support that one. All right, so let's go to all right, so let's go. I think the Zoom screen is here. The person dropping off here. All right. I think this. All right. So if you have that down, this is just to summarize what you guys would have learned already. All right. It's a neutral atom. You're losing electron forms cation, gaining electrons forms the anion. All right. Now, look at this little look at this little meme. Everybody seeing this?
Yes, sir.
Yes, sir.
All right. Can anybody tell me in their own words what this think is happening here? What does it look like it's happening?
Sir, the anion is taking the electrons, sir.
The anion. All right, where's the anion? Because I'm not seeing the anion on the screen. I'm not seeing nothing like that. I'm not seeing the word anion or cation. I'm seeing something on the screen, but I need to know what is it that what you seeing. I don't know. You're struggling because from your eyes working, you're supposed to can't tell me what you're seeing. Yes, Tiana?
Sir, sodium is running away from the electron, sir.
No man,
So,
talk up, man. Now ears. You talk, wake up, man, and talk.
sir, sodium is running away from the electron, sir.
Very good. All right, sodium is running away from the electron. Very good point there. All right, sodium is saying something. And how you know that it is sodium, by the way?
So Na means sodium. So
All right. So, all right. Na means sodium. Very good. So I hope everybody is heard what Tiana just said. And I hope everybody understand what is happening here. If you guys don't know what's happening here, it means that you have not done enough chemistry. And this was done from last term. The name of the element them. So Na means sodium. And then as Tiana said, sodium is running away from the electron. All right, what is sodium saying here?
Taking it, sir. Chlorine taking the electron.
Okay, very good, Christian. That's you, yeah. Definitely chlorine is saying don't mind if I do. Yeah, so that means chlorine definitely wants the electron. All right. And so that is the story here. So, all right, so this is how elements behave, guys. We have this could work for many other other elements. It could work for. Let me see if we can find other elements that behave in the same way. But then this is just something that you need to understand. So elements have and let's look at sodium first of all. Let's look at what the structure of sodium is and what the sodium the structure of and so atomic structure of sodium is something that you should be familiar with. All right. Atomic structure of sodium. All right. So let's show you this. I want to find a nice little model for you guys so you can actually see it here. Nothing too complicated here. All right. All right, let me talk about this then. All right, there you go, guys. So yeah, everybody seeing this?
Yes, sir.
yes.
All right. So this is the sodium story now. This is the story of sodium. All right, atomic number of 11 because of this. Let's change the color here. Let's put it in red so you can see it here. Atomic number of sodium is 11. Let's not draw over the atom, over the electron, I should say. All right. So everybody's seeing that the atomic number is 11 and there's 11 plus there because what protons have positive charge. So atomic number is the same thing as the proton number. Protons have positive charge, so it's 11 plus there. All right. By the way, this down here so is actually groups. So and then of course going across here is what we call periods. We're going to learn these things later on. But important things to know there. All right, anyway, so sodium has 11 protons and it should have 11 electrons. And okay, so 2 on the first. And notice that we come across this information here, electronic configuration, right? This is telling you how what the electrons are arranged on the shell. The first shell can have more than 2, so electronic configurations will start well with, except for hydrogen, definitely all of them start with 2. So this now is the first shell. All right. This 8 is on the second shell. And then of course this 1 is on the third shell. All right, so that is it. So now we look on that third shell and there's that 1 electron there. All right, so now, and in the meme, in this picture here, sodium does not want that 1 electron. All right. Now, why doesn't sodium want that 1 electron? All right. So imagine that you have some women who have a lot of children and they live in a small house. And then you know, and find another guy with him like and have another child for him. See the problem there, guys? House full, woman pregnant, one child, one more child. So what option she have there? She don't want to abort the child. She decided to carry through the child, having the child. What option she have there?
Sir, give him to him father.
Yo, I love that. Hold on. Lori, you say give to your father. That's what you say, Lori.
Say, but what if your father gone the first and no man the pity, sir?
Well, that is
Or
another case.
adoption.
Adoption. Christian saying adoption. All right. Love that. Love that. So that's what happened here in the meme, you know. So them say, boy, you know, never full shell this one, you know, this one, you know, me have to go add on for my house and I don't have no money and sitting. So just take it, just take that picture. So yeah, find somebody who want it. In the case of this, chlorine wants the electron. Does chlorine have the space for this electron? Why is chlorine so eager to get that electron? All right, let's look at the atomic structure of chlorine and see what's happening. All right, so let's go here to chlorine, and we're finding the atomic structure here. All right, this one though has it in terms of the ion. Let's see if I can find it with the atom here. All right, not quite. So I'm gonna actually send this image on the screen right now, guys. Have a look at this one. And I'm going to duplicate this side here. All right, no problem. I'm going to take off this. And there you go, guys. Everybody seeing this now?
Yes, sir.
All right, so that's what happens here. Chlorine has 17 protons, 17 plus. Chlorine is right here on the periodic table. Here, chlorine is actually in group 7, something that you're going to have to know for CXC exams though. Chlorine is actually in group 7. Here is group 1, group 2, group 3, group 4, group 5, group 6. Chlorine is in group 7. All right, so now there is chlorine all the way over here. We just talk about sodium all the way there. And there is the case now. So chlorine decides to take that one electron there, and now it has 18 electrons. All right, that will change the chlorine atom into the chlorine ion. And so that's the explanation there. All right, chlorine actually has 7. So I need to get a better let me show you a better image of this one, because I wanted to see the 7 electrons that chlorine had before this happened. All right, let's duplicate this again and see what's happening here. All right, and let's remove that, take off that. All right, look at this now, guys. Yeah, that's it, chlorine. All right, so that's actually called chlorine 35. But then this is what we're seeing here. All right, so if we look at it now, the last shell, so this is the first shell, second, and third. All right, how many are you seeing on the last shell?
7.
7. All right, how many more can it hold? What is the most that the third shell can hold?
Sir, 1.
What's the total number of electrons that can be stored on the third shell? That's the question.
8, sir.
8. Total number. And then Laura is saying that one more would carry to 8, because it's 2, 8, 7 now, guys, right? So 7 there, but it can hold 8. So chlorine will say, all right, you know what? I want to fill up that room here still now, so maybe just take it from you then. And bam. So what? Sodium and chlorine are in business together. All right, and that business now is what happens in chemistry. where compounds are formed. So that actually forms what we call a compound. But we're going to talk more about that next class, which is on Friday. All right, guys. So you guys have any questions here?
No, sir.
All right. Good. So I'm just leave you this information here. All right. So, all right. And I'm going to put for CSIC purposes, because since this is being recorded, you know, people might be out there saying, but why is this teacher teaching that the third shell can hold up to 8? Well, yeah, at CXC level, yeah, that's true. But beyond CXC, that's another story. But I'll get into more details there next class, guys. So anybody writing off anything? Or what I will do then, I'll send this in the group then, guys. And I have not taken the register. All right, let me just be able to duplicate this and see. All right. Let me see. Everybody on this list here. I'm going to change this to the 21. Yeah, so it's going to be the 21st. Let me change it to white as well. All right, so here we are, guys. Anybody not seeing a name here? No, Sasha K not here today. Did see Jamila. And yes, Jamila is there. So let's add Jamila. All right. And there's also Christianity. There's Lori. Yes, Lori is there. All right. And then Ruda. Ruda is there. All right. So this looks good. All right. 21st at the 4:21. All right, guys. Thanks for being here today. And hope you enjoy the rest of your day. I also hope that you learned something today as well. You sounded good this morning. You were able to tell me things that I expected you to know. So that's good. So let's keep that up. And remember now for next class, we're going to continue with this, guys. What I want to look at, I want you to be able to explain how ions are formed for each of the first 20. You must tell me what type of ion they will form and why. All right. So for example, can hydrogen form a cation or an anion? You should remember what anions and cations are. So next class, we're going to look at that. All right. And also I wanted to tell me the 3 elements in the first 20 that will not form ions. There are 3 of them in the first 20 that will not form any ions whatsoever. All right. And you're going to tell me that next class. All right. So what 3 elements? Yeah, what 3 elements are, and in this case, atoms will not, all right, will not form ions. And we're talking about naturally. That's a question for next class. And why? All right. So hint is that use, no, that's not actually hint. Just elements, use elements 1 to 20. 1 to 20. All right, so this is for next class, guys. All right, guys, so I'll see you guys on Friday. And I'm gonna try and send this in the group.